Hi friends. Welcome to the YouTube channel DM Info Videos. We are here today with an interesting new video to enlighten the viewers. Continue watching this video till the end so that anybody will come to know about the much unfamiliar information and wait eagerly for the episodes to publish regularly. Please like and comment, share, subscribe and tap the bell icon for receiving the notifications on the upcoming videos. Trust that everyone must have watched the previous videos that were published. If not, please click the links given below to know them and share. Episode 14. In this episode, we will learn about prestressed concrete, used for civil engineering construction. It will speak in this video with an introduction, necessity, advantage and disadvantage, types such as pre-tensioning, post-tensioning, bonded and unbonded, and materials under this topic. Introduction. In ordinary reinforced concrete, stresses are taken care of by the steel reinforcement, whereas in prestressed concrete, the entire concrete area is to resist them. It utilizes the maximum compressive strength of concrete and the tensile strength of steel to tackle the stresses. The prestressed concrete structure is a product that allows the determined and engineering stresses to act upon to counteract the stresses that develop when subjected to load. In a prestressed concrete member, the internal stresses are introduced in a planned manner so that the stresses resulting from the superimposed loads are counteracted to the desired degree. Imagine a barrel made of wooden staves and metal bands. Tung Yen Lin, a civil engineering professor at the University of California, explained it in the introductory chapter of his book Design of Prestressed Concrete Structures. The principle of prestressing applied to construction, perhaps centuries ago, when ropes or metal bands were wound around the wooden staves to form a barrel. When the bands tightened, they were under tensile stress, which created compressive stress between the staves and enabled them to resist hoop tension produced by internal liquid pressure. Prestressed concrete is one of the most reliable, durable and widely used construction materials in building and bridge projects globally. It is used in floor beams, piles and railway sleepers, and structures such as bridges, water tanks, roofs and runways. It experienced a tall growth in the construction of shopping centers, auditoriums, gymnasiums, and cafeterias because of its acoustic properties and its ability to provide long, open spaces. Why required? Reinforced cement concrete is good at compression but very weak in tension. Steel bars at the bottom resist the most and save concrete from cracking. In long spans for bridges across rivers, flyovers, more beam depth is necessary, which has practical difficulties. Advantages and disadvantages. The advantages of prestressed concrete include: longer span lengths increase the usable unencumbered floor space in buildings and parking. The cross-section of a member will be small even for a long span and loading condition. A composite member is formed after joining individual precast concrete units. The inherent compressive strength of concrete is used to its fullest. The special alloy steels used to form the prestressing tendons used to their fullest. The longevity of the prestressed structure is greater than the RCC structure because the reinforcement stays unaffected by external influences. Tension cracks are eliminated, reducing the risk of the steel components corroding. Shear stresses reduced. Lower maintenance cost over the design life of the structure, since no joints weakness in concrete buildings. Prestressed concrete is more economical when spans are over 9 meters. The disadvantages of prestressed concrete include: high degree artistry and control is required. Special alloy steels are more expensive than traditional steels used in reinforced concrete. Expensive equipment is needed. There are complex safety requirements. Most of the pre-tensioned concrete products are prefabricated in a factory and transported to the construction site, in which the sizes are limited. Types of pre-stressing: pre-tensioned concrete and post-tensioned concrete. While pre-tensioned concrete uses tendons directly bonded to the concrete, post-tensioned concrete can use either bonded or unbonded tendons. Pretensioned concrete: in this, tendons located within or adjacent to the concrete tensioned before the concrete cast. This method produces a good bond between the tendon and concrete, which protects the tendon from corrosion and allows direct tension transfer. Higher bond strength in early-age concrete will speed production and allow more economical fabrication. Pre-tensioned tendons are usually composed of isolated single wires or strands, which provides a greater surface area for bonding than bundled-strand tendons. However, it requires stout anchoring points between which the tendon stretched, and so the tendon usually forms a straight line. Pre-tensioned concrete is the most commonly used fabrication of structural beams, floor slabs, hollow core planks, balconies, lintels, driven piles, water tanks and concrete pipes. Post-tensioned concrete. Each end of a tendon is an anchorage assembly firmly fixed to the surrounding concrete. In this, tendons are tensioned after the surrounding concrete structure is cast. The tendons are not placed in direct contact with the concrete but encapsulated within a protective sleeve or duct, either cast into the concrete element or placed adjacent to it. Once the concrete is cast and set, tensions are created in the tendons by pulling the tendon ends through the anchorages while pressing against the concrete. Bonded post-tension concrete is a descriptive term in which compression after pouring concrete and the curing process, in situ. Concrete for the tension occurring areas of curved ducts of plastic, steel or aluminium is done. A set of tendons is fished through the ducts before the concrete is poured. Once the concrete hardens, the tendons are tensioned by hydraulic jacks that react against the concrete member. When the tendons are stretched sufficiently according to design specifications, they are wedged in position and maintain tension after the jacks are removed, transferring pressure to the concrete. The duct openings are then grouted to protect the tendons from corrosion. The advantages of this system over unbonded post-tensioning are: reduction in traditional reinforcement requirements. Tendons can be easily weaved, allowing a more efficient design approach. Higher ultimate strength due to the bond generated between the strand and concrete. No long-term issues with maintaining the integrity of the anchor. Dead-end unbonded post-tension concrete differs from bonded post-tensioning by providing each cable with permanent freedom of movement relative to the concrete. In this process, each tendon is coated with grease and covered by a plastic sheathing formed in an extrusion process. The transfer of tension to the concrete is achieved by the steel cable acting against steel anchors embedded in the slab. The disadvantage over bonded post-tensioning is a cable can distress itself and burst out of the slab if damaged, such as during repair on the slab. The benefits that unbonded post-tensioning can offer over bonded systems: ability to be prefabricated, improved site productivity, improved installation flexibility, reduced concrete cover, simple replacement and adjustment, superior overload performance. Materials: concrete. Stronger concrete is required for prestressed when compared to reinforced work. The current practice calls for a minimum 28-day cylinder strength of 5,000 psi or 350 kgs per square centimeter. When the concrete is not adequately strong and stressed by tendons, it leads to crack or failure. The high compressive strength offers higher resistance to tension and shear. High-strength concrete is subjected to lesser shrinkage crack. It has a high modulus of elasticity and less creep strain. As a result, the loss of prestressing is less. Steel. According to AASHTO, high-strength 7-wire strand, a high-strength steel wire or alloys of grade and type specified by the designer should be used in prestressed concrete. The steel used for prestressing may be in the form of wire or tendons that can group to form cables. The wire is made by cold drawing a high-carbon steel rod through a series of reducing dies. The wire diameter typically ranges from 3 to 7 mm and may be round, crimped or indented to better bond strength. Another form of the tendon is a strand of straight core wires wound in helixes around further wires to give formats such as 7-wire, 6/1, and 19-wire, 9/9/1. Similar to wire tendons, the strands are placed either individually or in groups to form cables. Thank viewers for sparing your valuable time and watching Prestressed Concrete on this YouTube channel. DM Info Videos. It must have enhanced the understanding of prestressed concrete, placed everyone in a new light of exposure, and inspired us to learn more. Else, online technology helps us repeatedly viewing to get the benefit. Kindly wait for the following video to publish early. Keep watching the videos regularly published on this channel. Would you please share and subscribe for more fabulous inspiration? Thanks again and wishes to prosper ever.